Okay, today we are going to discuss about linear search and binary search. The first one is a linear search. Okay, so when the searching algorithm we can apply, that means we indirectly talking about the array. Okay, array. So array is given. So now see, this array is given. Okay, so array having some index value 0, 1, 2, 3, and 4. And index having some element like 8, 1, 2, 9, 5. So here, these are the input. So these are the input array, and array name, suppose I'm putting A and this one. So I cannot mention the size of array because we have to go for the unlimited. So now suppose I want to take output and I am going to put the index I value. Suppose I am going to put the I value is equal to 9, or maybe a index value. Suppose I want to print the 2. So sometimes I represent as an index, and sometimes we have to search the value as a 9. Okay, both they will ask you where the value is present, that print the output. So what we have to output, they will ask. So we have to print the output index with output, okay, and only output. So index with output, that means suppose I want to search the element 2. So it will print like this one, A of 2 equal to 2, okay, or like this one, only 2. So in linear search, we have to search an array to find out the element is present or not. Okay, so now suppose I want to search 5. So first what we have to do, so now A of I array is represented as I. Now that means A of I is equal to that search value is a 5. Then this condition we apply in a if condition. If this is possible, then we have to print the element is present or not present, or print output. So that is the concept of linear search. So for that purpose, we have to do without passing the argument. That means we have to create a function. It is possible we have to create a function. अगर आप function create करने में interested नहीं हो, तो all the lines should be written in the same code. Okay, but when you try to write a function, the code is very easy. कि आपको समझ में आ जाएगा हम function use क्यों करते हैं, because your code look like a very easy and very easy to identify which block is what purpose. Okay, so our task is, so we have to take an input of array of size anything, then we have to decide or pass the one a linear search function where you have to pass the array, where we have to pass the size of the array, and where we have to pass the element whatever you want to search, like x. Okay, and this is the function. So here what we have to do, yeah, Lipsa, any doubt? Oh, Lipsa, by mistake maybe. Okay, so linear search, what we have to do, suppose if you are writing a function, I'm talking about function. Suppose you write a function, that means we have to pass the array, that is the array, that is the size of the array and the element whatever you want to search. So in the search element, what you have to do, simply we have to write int I, because we have to define A of I. So for loop, in for loop will be start from I equal to 0, I less than equal to n, and I plus plus, or inside that what we have written, if A of I is equal to whatever the value of x, what I suppose you want to direct, I'm putting the 9. Suppose you want to pass 9 here. Here you want to pass the variable also. So 9, then return something else, and close this. Okay. So this is the process we have to write the code of linear search. So I hope this one is the easiest search among all search. Okay, now see. So what is the best time, then average time, then worst time? Okay, now see this array. What happened? If worst condition I'm talking about, suppose my element is present at the end of the array, so I have to search here, then jump here, then again here, then again here, then again here. So that means if my array size is a 5, then how many times I can travel? 5 times. Suppose array size is n times, then how many times I can travel? N times. So time complexity is order of n. That means big of n. Worst time complexity. Now see, in average time complexity, so average time complexity, that means it may be a first element, it may be a last element, it may be a second last element. So on an average, we have to travel n times. So my average time complexity is also is order of n. Now, the best time complexity, suppose I want to find out the element and my element is present at the 0th position. So that is the best time complexity. That means how many comparison only need? Only one comparison. That means order of 1. So in the best, order of 1, average, order of n, and worst, order of n. Okay, so suppose if you apply the linear search on the large database, it will take more time. So ये सही नहीं है. So that is the use of the search algorithm. Basically small database के लिए हम लोग linear search करते हैं. और basically हम लोग अपने real life में भी we can go for the linear search. जैसे ना, suppose if you want to find out some stuff or elements in your room, then what you have to do? One by one ना, आप पहले कबर्ड चेक करते हो, फिर अपना बैग चेक करते हो, फिर अपना बॉक्स चेक करते हो, फिर अब कबर्ड के ऊपर का भी अगर कुछ रखा है तो उसके बाद चेक करते हो. ऐसा तो नहीं ना सारा एक साथ एक, not possible, step by step process. So that is the use of linear. Okay, so please write this code and share with me. Okay, so online student, please write this code and share with me. First linear search, then I can discuss about the thank you Rohit. First element. Okay, so first write this code linear search. If you interested to write this code is with function, that is good. So make a habit to write a code with function. आप लोग habit डालिए function के साथ लिखने का. Okay, so that is a very useful for you. After this, I can discuss about the binary search. I'm not discussing about the binary search tree. Binary search. Okay, so linear search, then binary search. Very important. Okay. Please write this code and at least hardly it will take only 15 minutes to write this code. Linear search. So now suppose I'm going to put a hint for you. So I'm going to write this one. Okay. Suppose I'm going to write a search. This function I'm going to write. This n is the size of array, and the int is the x, that the element we have to search. Inside that I'm defining int I. Then for that one I have to write a for loop. I equal to 0, I less than n, and I plus plus. Okay, inside that I'm going to write a if a of I is equal to x, then whatever you want to return I. Return I, that is the index value, that present or not. Otherwise, return -1, that means negative value, and close this one and close this one. So this is the function I'm writing. most of the work I can do that for you, and you have to write a main function. Okay, you have to write a main function. Inside main, we have to declare all the things. Please do this code. Anyone completed online? Okay, Dharam. Anyone completed online? Anyone completed online? Dharam, Rohit, okay, and others. So please don't copy and paste. Okay, these things are your copy. Now see this one, linear search. That is a copy or that one. Okay. हर बार वहीं पे गलत करते हो तुम, वहां पे पास नहीं होता यार ये। So next one, try binary search. Binary search try करो. बाइनरी सर्च ट्री है वहां पर, ये बाइनरी सर्च है। ये तो आपका सी का ही है ये सब पार्ट। ओके, चलिए, सो हम लोग डिस्कस करने वाले हैं बाइनरी सर्च। The next program is binary search. Okay. कोड भी सही है, अब जो प्रीफर करना करो। वो पूरा नहीं लिखना, हाँ वो आ जाता है। पहले जो फॉर्मेट सेट करते थे इंक्लूड वाला वो सब एमएल में नाम नहीं नहीं, तो वो प्रोजेक्ट में इसे करके बना सकते हो, कोड ब्लॉक में भी बना सकते हो, जो सी प्लस प्लस में आप प्रोजेक्ट क्रिएट कर दो, प्रोजेक्ट में वो डिफाइन हो जाएगा। ओके, नाउ सी, सो बाइनरी सर्च, so binary search is that suppose array is given. Now see the difference. Suppose array is given in a normal search. So what is the array given? Like this one, 0, 1, 2, 3 and 4. The array is given like this one. Yes or no? In the previous one, whatever you have done, you're searching. So array is randomly, not sorted order. But in binary search, array is given in the sorted order. Then we have to find out which element is present or not. Okay. So most of the time, binary search is given in the sorted order. Okay. Now see. So what will be the given like this one? Now see. So it will be given like this one: 1, 5, 8, 9, 20, 25, like this. And this is a binary search. That means array is already sorted. then we have to search this element is present or not. Okay, then this element is present or not. Suppose I want to search 20. Okay, so I want to element find out the 20. So now how can search? Okay, so here is important is sorted array. हमने ये वर्ड कहीं यूज नहीं किया है कोई भी सर्चिंग में, सॉर्टेड एरे, बट इन बाइनरी सर्च एरे इज गिवन इन फॉर्म ऑफ सॉर्टेड एरे. ये बहुत इंपॉर्टेंट पॉइंट है. सो दैट इज द की पॉइंट. अगर आपसे पूछेगा कोई कि हम कोई नॉर्मल अनसॉर्टेड एरे पर बाइनरी सर्च लगा सकते हैं, नॉट पॉसिबल. सॉर्टेड एरे. अब अगर बाइनरी सर्च ट्री वी कैन अप्लाई ऑन अनसॉर्टेड एरे, वहां पे ट्री का कॉन्सेप्ट आ जाता है, बट यहाँ पे अब देखिए. सो array is given. Now sorted array given. So this one is a 0 1 2 3 4, and my point is let's suppose 8 10 15 16 and here 21. Suppose I want to search 16. So how to search? The first phase of binary search we include that कि we start from here. हमें यहाँ से start करना है first time. Okay, then when we are starting the searching, so we have to start from node number 0. After that we have to divide this array into two half parts. Okay, two half parts. So that means we have to find out the middle element like a merge sort. अगर merge sort का concept पता है तब binary search complete हो गया. So now suppose how? So this is the lower element, this is the higher element. So when if r is greater than equal to 1, that means हमेशा r की वैल्यू जब greater than 1 होगी तो हमें partition करना है. That means we have to find out middle element each and every time. And how can find out the middle element? Now simple. So now see. So middle element के लिए हम क्या है? Middle element left plus r minus f divided by 2 जो हमने मर्ज सॉर्ट में देखा था. तो हमें यहां पर क्या मिला? 0 plus 4 by 2 divided by 2. So this is the my middle element. Okay, so now after calculating middle element, then we have to comparison to our searching element. मुझे सर्च क्या करना है भाई? 16 सर्च करना है. Then we have to find out where 16 lie. If a of 16, middle element is greater than our searching element, then my element lies at the left hand side, otherwise right hand side. Then again go for the division, and again go for the division, and then we have to find out the clear. So now suppose writing if a of middle element is equal to x, then return x and return m whatever I value. Okay, अगर हमारा if a of what I am writing mid is greater than x, then we have to search left hand side. So how to search? Again we have to call search operation of binary or left and mid minus 1. ऐसे ना हो गया ना. और ज्यादा होगा तो array m plus 1 comma r, फिर लास्ट में मर्ज कर दो. क्लियर? कुछ समझ में आया? मर्ज सॉर्ट समझा है आप लोगों ने? एक मिनट देखिए, यहाँ देखिए, हमें मेन हमारा फोकस होना चाहिए मिडिल एलिमेंट पे. ओके, सो आई हैव टू फोकस ऑन मिडिल एलिमेंट, एंड हमें जो हमारा एलिमेंट है जो सर्च करना है उससे कंपैरिजन करना है मिडिल एलिमेंट के साथ. और हमारा रिजल्ट कब आएगा? जब मिडिल एलिमेंट इज इक्वल टू सर्च एलिमेंट देन रिजल्ट. तो दैट इज इंपॉर्टेंट. आप समझ में आ गया होगा. तो इसीलिए हम हर डिवाइड कर रहे हैं और मिडिल एलिमेंट को फाइंड आउट कर रहे हैं. ओके, ठीक है. Okay, please do this code and share with me. Anyone doubt regarding binary search? So please binary search you can do. Now see what we have to do. actually we have to comparison with only middle element and search element. Where middle element equal to search element, then our search is over. Please everyone mark your attendance here in a chat box. Please everyone mark attendance here. Okay. Okay. After mark your attendance, then you can leave. Please mark your attendance. Isha, Jansi, Lipsa, Rahul, Rohit, Urvisha. ये दो हैं. Okay.
Sir, 89 Rahul.
Please mark your attendance and please. Yes, Rahul.
89 present, sir.